This is a technical bulletin about Husky Corporation's 3/4 inch multiplane swivel, the 350. Having a swivel included in fueling equipment is important. It helps the nozzle sit in a vehicle in the correct position, it helps prevent hose kinks and twists, and prolongs the life of the hose. It's common sense that you'd want equipment that swivels as easily as possible. Husky wanted to find out how we stacked up against the competition, so we took our 3/4 inch multiplane swivel and put it to the test to see how easily the joints swiveled. Husky's Model 350 swivel has precision machined journal bearings, fluorocarbon and fluorosilicone O-ring seals, and uses E-clips for safe and dependable retention in the nut and mid joint. To test how much force it takes to swivel the joints, the swivels were mounted on a torque table and the rotational axes of the table and the swivel joint were aligned. A 3D printed fixture helped make sure the mid joints were in the correct position. The full range of travel was tested in 90-degree increments, clockwise and counterclockwise. The average torque was calculated and plotted for each of the sample's nut and mid joints. So the Husky swivel on average took about 1.76 inch-pounds to swivel the nut joint and 2.82 pounds to swivel the mid joint. Over all the samples that we tested, the nut torque varied within a range of 2.07 inch-pounds and the mid joint varied within a range of 5.53 inch-pounds. Here's the results of the three competitors that we tested. They took 10.29 inch-pounds, 5.99 inch-pounds, and 7.9 inch-pounds to swivel the nut joint. It took 10.68 inch-pounds, 6.18 inch-pounds, and 6.95 inch-pounds to swivel the mid joints. The competitors' nut joint torques varied within a range of 3.9, 2.5, and 14.9 inch-pounds. And the mid-joint torques of the competitors varied within a range of 8.09, 3.16, and an astounding 16.3 inch-pounds. So what does all that mean? As we mentioned earlier, the low swiveling force helps the nozzle sit in the vehicle correctly, prevents kinks and twists in the hose, and prolongs the life of the hose. According to our tests, the 350 swivel is going to do the best job at that. The smaller the variation in the torque data, the more control the manufacturer has over the manufacturing processes that go into making that swivel. Over all of the samples, Husky's rotational force varied by 2.07 inch-pounds. That's an extremely consistent performance from part to part. The competitor varied by 14.9 inch-pounds. So we're interpreting that data as an indication that the manufacturer has a hard time making the same thing twice, or maybe they're choosing to make a less consistent product to save money. So how does Husky keep that variation so small? Here's an example. A particular dimension on the journal is machined within a 0.03 of an inch tolerance range. A piece of printer paper is 0.04 of an inch thick, so that means that the dimension on the 350 swivel is allowed to vary less than the thickness of a piece of paper. If we find a part that's outside of that tolerance range, it's rejected. We don't use it. We work hard to control our machining processes. We track them over time and look for trends. Just on Husky's 3/4 inch multiplane swivel, we track over 62 dimensions. That's how we produce the easiest swiveling, most consistent, highest quality fuel swivels on the market.